The 8051 microcontroller is a widely used 8-bit microcontroller with a 40-pin dual inline package. Here's a breakdown of its pin configuration. Power and clock pins: VCC, pin 40. Power supply, GND, pin 20. Ground connection, Xtal1 and Xtal2, pins 18 and 19. External crystal oscillator inputs. I/O ports: Port 0, pins 32 to 39. Multiplexed address and data bus can be used as general-purpose I/O. Port 1, pins 1 to 8. Dedicated I/O port, Port 2, pins 21 to 28. Higher order address bus or general-purpose I/O. Port 3, pins 10 to 17 I/O, with additional functions like serial communication, interrupts, and timers. Control and special function pins: RST, pin 9. Reset pin, active high. AL, pin 30. Address latch enable. PSEN, pin 29. Program store enable, used for external memory. EA, pin 31. External access enable determines internal or external memory usage. Each port can be configured as input or output, and some pins have alternate functions like serial communication, RxD and TxD, external interrupts, INT0 and INT1, and timers. ARM microcontrollers come in various types, but one commonly used model is the LPC 2148, based on the ARM 7 TDMIS processor. Here's a quick overview of its pin configuration. Total pins 64 organized into ports. GPIO ports. Port 0 is a 32-bit port with 28 pins configurable as general-purpose I/O, 1 pin for output only and 3 reserved. Port 1 is also a 32-bit port, but only 16 pins are available for general-purpose I/O. Special function pins, power and clock pins, include VCC, GND, and oscillator inputs. Communication interfaces feature UART 12C and SPI. Analog and PWM pins offer 10-bit ADC and DAC for signal processing. Timers and debugging include a watchdog timer, real-time clock, and debugging interfaces. It looks like you might be referring to the LPC 1768 microcontroller, which is based on the ARM Cortex-M3 architecture. Here's a quick overview of its pin configuration. Total pins. Typically, there are 100 pins in an LQFP package. GPIO ports, Port 0, and Port 1 each have 32 pins, with multiple functions like UART, SPI, I2C, PWM, and ADC. Port 2, Port 3, and Port 4 have fewer available pins, mostly used for specific peripherals. Special function pins. Power and clock pins include VCC, GND, and oscillator inputs. Communication interfaces: UART Y2, CSPI, and CAN. Analog and PWM pins, 12-bit ADC and DAC for signal processing. Timers and debugging. Watchdog timer, real-time clock, and debugging interfaces. PT32 microcontrollers, developed by Microchip Technology, are based on the MIPES32 architecture and are widely used in embedded systems. Here's a general overview of their pin configuration. Total pins varies by model, typically ranging from 64 to 144 pins. GPIO ports, configurable digital I/O pins, and supports interrupt-on-change functionality. Special function pins include several key types. First, we have power and clock pins, which encompass VCC, GND, and oscillator inputs. Then, there are communication interfaces such as UART, SPI, I2C, CAN, and USB. For analog and PWM pins, we have 10-bit ADC and PWM outputs. Lastly, timers and debugging features include the watchdog timer, real-time clock, and JTAG debugging. PC-18 microcontrollers, developed by Microchip Technology, are part of the 8-bit PIC family and are widely used in embedded systems. Here's a general overview of their pin configuration. Typically, PIC-18 microcontrollers come with 40 pins in a DIP package. Regarding GPIO ports, we have port A, port B, port TC, port D, and port. Each port has multiple pins for digital input and output. Additionally, they support interrupt-on-change functionality. Special function pins, power and clock pins include VCC, GND, and oscillator inputs. Communication interfaces encompass UART, SPI, I2C, CAN, and USB. Analog and PWM pins feature a 10-bit ADC and PWM outputs. Timers and debugging include a watchdog timer, real-time clock, and JTAG debugging. PC-18 microcontrollers, developed by Microchip Technology, are part of the 8-bit PIC family and are widely used in embedded systems. Here's a general overview of their pin configuration. Total pins, typically 40 pins in a DIP package. GPIO ports, port A, port B, port C, port D, and port. Each port has multiple pins for digital I/O and supports interrupt-on-change functionality. Special function pins, power, and clock pins includes VCC, GND, and oscillator inputs. Communication interfaces, UART, SPI, I2C, CAN, and USB. Analog and PWM pins, 10-bit ADC and PWM outputs. Timers and debugging, watchdog timer, real-time clock, and JTAG debugging. The STM32F103C8T6, commonly known as the Blue Pill, is a popular Arming Cortex-M3 microcontroller. Here's a quick overview of its pin configuration. Total pins. Typically 48 pins in a LQFP package. GPIO ports, port A, and port B. Each has 16 pins, supporting multiple functions like UART, SPI, I2C, PWM, and ADC. Port TC, limited to 3 pins, PC13, PC14, and PC15. Special function pins include several categories. First, we have power and clock pins, which include VCC at 3.3 volts, GND, and oscillator inputs. Next are communication interfaces, UART, I2C, SPI, CAN, and USB. Then there are analog and PWM pins, featuring a 10-bit ADC and PWM outputs. Lastly, we have timers and debugging, which include a watchdog timer, a real-time clock, and JTAG or SWD debugging. Arduino microcontrollers come in various models, each with unique pin configurations. Here's an overview of the Arduino Uno, one of the most popular boards. Power and reset pins. VIN is for external power input. 5 volts and 3.3 volts are regulated power outputs. GND stands for ground connections. And reset resets the microcontroller. Analog and digital pins. Analog pins, a 0 to A5, are used for analog input in the 0 to 5 volts range. Digital pins, 0 to 13, can be used as input or output. PWM pins, 3, 5, 6, 9, 10, and 11, provide pulse width modulation output. Communication and special function. Pins serial 0RX and 1TX are used for UART communication. SPI, 10SS, 11 MOSI, 12 MISO, and 13 SCK are used for SPI communication. I2C, A4 SDA, and A5 SCL are used for I2C communication. ARF provides reference voltage for analog inputs. Each Arduino model has variations in pin configurations.